joining. This session is going to be on application of TensorFlow, like applicability of TensorFlow. This is mostly a beginner session, so you don't need to have any prior knowledge of machine learning. We'll just explore the basics of TensorFlow and how it can be utilized. The main goal or the main objective of this session is for you guys to have an understanding of the applications part that's going on, especially in India, and how you guys could contribute. And if you have any ideas, I would especially love to hear them. And of course, you can reach out to a lot of people, including your own TensorFlow user group in Mysore, for the same. So before we start, I just hope that every one of you are, are staying at home and making the most of the time that we have. I know this must be a very tough stage for everyone. But yeah, I think it also. I mean, all these difficult situations helps you become the person that you really are. So I always welcome changes. I always welcome difficulties and predicaments. Of course, they are pretty difficult or really hard, but on the other side, when things get better, each and every one of us will come out to be a better person. So having said that, let's quickly start. Let's jump to applicability of TensorFlow. So I've discussed the session. So this will more be like a discussion. At the end of the session, we will have some sort of Q&A. So either it could be directly through YouTube Live, or what I would recommend or what I would encourage is probably reach out to me after the session. If you have any questions, you can connect to me on LinkedIn, or you can connect to me on GitHub. And if you have any ideas, I would love to hear them. So before we start, just wanted to show my gratitude towards TensorFlow user group Mysore for organizing the event. And of course, I know in these times, especially, it is difficult, for people to organize such events. But I feel that at this point, because we get a lot of time at home, we can learn a lot of new technologies, a lot of new, a lot of new stuff that we procrastinated. So a big thanks to the TensorFlow user group from Mysore. A bit about myself. My name is Akshay Bahadur. I'm an SD at Symantec, where I work in the big data and the analytics team. I'm also an Intel Software Innovator, and I'm also a Google Developer Expert. So both these companies, Intel and Google, have been really kind, and they have a program where they encourage young innovators to come forward and present their work. So especially Google, because I feel that they are especially trying to make sure that young talent in the field of machine learning come forward, and they provide a very uh, they provide their inputs. So I think this is a very valiant effort. All right, so let's quickly start. So before I start the video, I just want to discuss the inspiration behind me getting into machine learning. So initially it was just for fun. I started back in 2017, and I thought that machine learning was the hype at that time. So I thought that why not just ride the train and see where it goes. And then I saw this video in 2018, if I'm not wrong, end of 2018. A friend of mine showed me this video, and this completely changed my whole outlook. So this video is about a girl. Her name is Tanya, and she had her own problems. But even after her problems, she is living a very fulfilling life. And at the same time, she also helped Google's keyboard team to help to integrate a very specific piece of software, so that the Google keyboard can help the especially able in the United States. So we'll discuss more on the issue. I'll first play the video, and I hope that you guys enjoy it, at least draw some inspiration. So we'll discuss more after the video.
Hi, I am Tanya. This is my voice. I use Morse code by inputting dots and dashes with switches mounted near my head. As a very young child, I used a communication word board. I used a headstick to point to the words. It was very attractive, to say the least. Once Morse code was incorporated into my life, it was a feeling of pure liberation and freedom.
See you later.
I think that is why I like skydiving so much. It is the same kind of feeling. Through skydiving, I met Ken, the love of my life, and partner in crime.
It's always been very, very difficult just to find Morse code devices, to try Morse code.
This is why I had to create my own. With the help from Ken, I have a voice and more independence in my daily life. But most people don't have Ken. It is our hope that we can collaborate with the Gboard team to help people who want to tap into the freedom of using Morse code.
Gboard is the Google keyboard. What we have discovered working on Gboard is that there are entire pockets of population in the world, and when I say pockets, it's like tens of millions of people who have never had access to a keyboard that works in their own language. With Tanya, we've built support in Gboard for Morse code. So it's an input modality that allows you to type in Morse code and get text out with predictions, suggestions. I think it's a beautiful example of where machine learning can really assist someone in a way that a normal keyboard without artificial intelligence wouldn't be able to.
I am very excited to continue on this journey. Many people will benefit from this, and that thrills me to no end.
So this was the whole story, and I found this quite interesting, uh, especially because coming from a difficult background, it's difficult for you to live your own life, but at the same time, Tanya helped not only herself but other members from the community, and for that, I believe that I think her efforts are commendable. Although I don't get a chance to actually talk to her, but one day I will definitely love the chance to actually talk and tell her that her experiences has really inspired a lot of people. So, so this is what I believe. I think in any piece of technology, whether it's machine learning or any other technology, if it helps actual people, if it helps mankind, I think then the purpose is solved. So, with that in mind, let's quickly jump to the main sections. So, before we start, we have an important link. So, if you wanna have a look at the slides, go to bit.ly/tfug-mysore, and once that happens, you will be transported to my slide. So, let's say if I click on this, you will be transported to this page on GitHub. And if you want to have a look at the slides, just click on this link. If you want to have a look at the meetup, click on this link. So you will get a lot of information on this page. And of course, if you have any issues, just go to the issue section and you can create a new issue and let me know if you require any help. So coming back, so before we start, this is going to be not a hands-on session. This is going to be mostly, I will try to explain what are the things that currently are going in machine learning, and uh, I will try to discuss the important functionalities or important applications in India's perspective, because I feel that the application, if it is successful in the US, might not be the same in India, because both of the countries have different infrastructure. So I try to discuss those pain points. But yeah, this is not a technical session, so anybody who does not have any knowledge about TensorFlow can also have a good time in this. So let's quickly start. So what is AI? AI is, to just on a simple term. So I'll just say that AI is basically giving intelligence to the system, and there are a couple of ways of doing it. One of them is machine learning, and that is by giving data. So if you give data and then you have an algorithm, your machine will learn automatically, and that is called machine learning. And there are other ways to give intelligence, but we'll not discuss that. We're here to only discuss about machine learning. But this is kind of an analogy that I follow. So this is, just to give you a heads up of the difference between AI and ML. So let's look at machine learning. So let's say we have an ordinary system. Okay. So let's say we have an ordinary system. Now we want to give it intelligence. We want to give it using machine learning. We want to make it a better system. So, for example, if I have to discuss something, let's say I'll probably want to discuss the use case of Gmail. So I think all of you must have used Gmail, and recently Gmail got a new feature of smart replies, which means that beneath every email you get, you have an option of smart replies, whether and that are very quick replies. So let's say if the person asks to set up a meeting, right, in the email, so either you can say that yes, I'm available, or no, I'm not available. So all these things are, we have smart replies. So we had an ordinary system, ordinary Gmail system. Using machine learning, we gave it intelligence, and now Gmail helps us reduce the tasks that we have. So let's say if I have to give a short reply, I can directly click on the buttons and then send an email. So it really helps. So to give an understanding, we have an ordinary system with the help of AI, basically giving intelligence. We use machine learning, that is, we give data to our system, and then over a period of time, our ordinary systems improves itself. It learns from the data and it gives predictions. So this is the kind of a viewpoint of how a machine learning system works. So we have an ordinary system, we have a machine algorithm, an algorithm which will learn from the data and it will improve over time. It will make predictions. So it makes sense. We'll quickly jump to the next slide. Uh, all right. So a couple of key points that we learned from the previous slide. Machine learning is basically learning. It's also improving, and it's making predictions. So this is how one of the basics, basic factors of when the importance, or these are the basic advantages that happen when we apply machine learning to an ordinary system. Now, the important aspect, I want to discuss the applications of machine learning or TensorFlow in detail. So let's look at some of the applications. So what we'll do in this session is we'll cover some applications from the United States, or not from India, and then we'll concentrate on applications from India and what are the other people doing and what have I done in this field and how could you help uh, you know uh, solving problems in India. So let's look at some of the international applications. So this is in the field of agriculture. Before we quickly start the video, I just want to give you a heads up. So this is from the field of agriculture. Um, and this is using machine learning. How can we improve agriculture? And I feel that uh, that video is quite helpful for Indian conditions as well. I mean, if you're able to replicate that for India, that's going to be really helpful. So let's look at the video. I'll discuss that after we seeing the video. So let's quickly jump to the video. So, so the video, I felt that this is quite interesting because first of all, this solves a very major issue, and at the same time, because India is mostly an agricultural state, if we are able to replicate the same thing or even similar thing in India, we are going to solve a lot of problems. Because usually what happens is with even with insecticides or fertilizers, we end up overusing it sometimes, and that is of course additional cost. At the same time, these fertilizers are chemicals, so if it gets washed down to the river or other water bodies, it's going to be poisonous for the fishes, and if we consume them, it's going to be poisonous for us. So instead of spraying the entire field, why don't we identify the crops that have the weeds and then try to reduce the surface area where the fertilizers are sprayed on? So it makes sense, and definitely replicating that to Indian conditions will be difficult, but I think it's doable and it's going to be really helpful because a lot of farmers. This is going to be helpful for a lot of farmers who don't have the resources to spend that kind of amount of money on fertilizers. So yeah, I think if somebody if a couple of people work on this use case, I think it's going to be very useful. Now we'll look at the next video. So the next video is from Tesla's autopilot kind of POC that they did on the streets of Paris. So this is before they designed the self-driving car. This is one of the initial stages. Let's look at the video. So I don't think that it has any audio, so I'll quickly try to make you understand my point of view when I saw the video. So this looks like one of the earlier things that they developed. So you can see that you have a car detection. All the boxes in red are cars. You have a pedestrian detection. So the boxes in yellow that you see on the right hand side of the screen, or the left hand side of the screen, are for detecting the pedestrians. And you will see some blue boxes as well that are for detecting the two-wheeler vehicles. And of course, you have the green path detection and the yellow lines, which is your lane detection. Uh, Now, the important point to notice here is that um, if you have to replicate that to India, it's slightly more complicated because of the population density. And at the same time, the roads might not be structured this well. So this is done on the streets of Paris by engineers from Tesla. But they actually give you a very good viewpoint that a technology like autopilot or a self-driving car can be done not easily, I'll say, but I still think that it's doable. So this was one of the videos that they did, and it's about 20 minutes long, where they traveled throughout the streets of Paris and they tried to see if their model was working or not. And I've also I've also added another video where some students from India are doing the same thing. So we'll discuss that when we get to it. But let's quickly just jump to the next video. So the next video is not, I don't think that it has a lot of applications, but I found it pretty interesting. So the next video is a research paper by the students of University of California at Berkeley. It's called as Everybody Dance Now. So I think when you see the video, it will make sense.
Lobster tail for dinner. Julio served that scampi. You got it if you want it. Got it if you want it. Said you got it if you want it. Take my wallet if you want it now.
So as you can see that the dance moves by Bruno Mars are being overlaid directly on the target 1 and 2, and they does not look very clean, but it definitely is quite. I mean, it performs quite well. So this can be used, I think, in some of the movie industries. I'm not exactly sure, but I found this pretty interesting. I found it fun to look at, and I found it pretty hilarious as well. So I included this in the video, and of course, um, it looked pretty cool. So now we'll come to AI in India and how are the applications that are really specific to India. And I've been trying to stress the importance of developing algorithms or developing models or even applications that are specific to India, because India has a very unique set of conditions that comes and that relates to the infrastructure, that relates to how the people react to different situations. So yeah, developing applications for India is quite different from developing applications for all over the world. So let's quickly jump to some of the videos that I collected, and these are collections I saw on LinkedIn, I saw on YouTube. So some of them are my own videos that I did some projects on. So the next video is the object detection on Indian conditions, and another one that is merged into the same video is pothole detection. So we are trying to detect the number of potholes on a road. So let's quickly look at the video, and you'll see a clear distinction. So clearly you see that the roads are a bit congested, and now you can see that vehicle and human detection. So you see that there are a lot of densely populated places, and mostly I think in India, if you're living in Mumbai or Hyderabad or Bangalore, or even Mysore, I think it's going to be slightly, dense. And now you have the little detection. So this is done, I think, on a highway, and things are much better. So yeah, so people have already started doing the work on Indian conditions, like for especially self-driving cars, but we are yet to see a good prototype. But definitely these are POCs and they have a good impact. So let's quickly jump to the next video. So the next video that I saw was from actually, so the next video that I saw was actually part of TensorFlow Roadshow in Bangalore, where I spoke at. And the next video is about a problem that is quite prevalent in Delhi, using the pollution. This video, I think, was pretty interesting because some students from a college, they came together and they identified a problem and they tried to provide a solution. And they were backed by Google. So Google helped these students because the use case was pretty unique. So let's look at the video and then we'll discuss about the issue in detail.
This is Delhi, the capital of India. It's the fifth most populated city on the planet and it's one of the most polluted. The smog you can see here is a mixture of fog, smoke, and other air pollution. It comes from dust, cars, burning fossil fuels like coal, and burning waste. Air pollution is determined by the harmful particles floating around, and it does not take many of them to start making the air toxic. However, people are hardly aware of the quality of air that they breathe in and the harmful effects it could have. We introduce Air Cognizer, an air quality analytics application that can help people stay more cautious about the air that they breathe in. The user clicks a picture of the sky from which certain features are extracted. The application also uses the geotag associated with the image to determine the current meteorological data of the nearest weather monitoring stations, which is obtained by making API calls to the server. After combining the extracted features of the image taken by the user and the meteorological parameters, the trained machine learning model provides the user with all details about the quality of air in the local area by processing all the data on the user's smartphone itself. Users are also warned about the adverse effects of the air that surrounds them. Incorporating both the image features and the weather data allows a more accurate estimation of the air quality. With the power of Google's TensorFlow Lite, MLKit, and Firebase, Air Cognizer provides an inexpensive solution to a real-time, accurate, portable, and adaptive air quality analysis to help the citizens of this polluted city stay safe from the poisonous environment surrounding them and make healthier choices.
So this is a team and the mentors, of course. So I saw the video and I found it pretty interesting. So the students had a problem at their hand, and although it's pretty quite saddening to see such an issue, but at the same time I'm pretty happy to see that people are addressing the issue. So this was one of the projects that I saw and I found pretty interesting. So I would encourage people that, if you have any ideas in your mind or any ideas that you want to work on and you feel that it is very specific to your place or your state and it is very close to you, so please work on that. We'll discuss how, what have I done and how could we take some pointers from that, but I think it's pretty very interesting. Okay, now let's look at another video, and this video is from Pune, where I work. And this video has also inspired me. It's about it's a story from a student named Ame, and how he worked at GDG Pune, and he had an issue in mind and he came up with a solution, and that is even very helpful for a specific a specific society in India, which I think has been underrepresented. So let's look at the video and we'll discuss it in detail, right?
When I was going to school, there was a deaf class in my school, and I was just curious how teacher is teaching the children who are actually communicating with each other with the help of sign language. So they were having that barrier to communicate with rest of the students.
Sound generally is passed to the eardrum. But when the eardrum is damaged, in that case, sound can be transmitted directly to the middle ear or inner ear through the bone. The problem with commercially available bone conduction hearing aid is that surgery is involved and the children cannot afford that much cost.
There are almost 16 to 20 million persons in this world who are not having access to any kind of hearing aid. I thought, can I help them with the help of some technology? In the childhood, as we learn like A, B, C, D, phonetics, vowels, pronunciations, they missed a lot of those things, and that was the main reason why we are having deaf as mutes, because they haven't heard any sounds since their childhood, that they cannot reproduce the sounds with the help of their tongue. I just thought if I can educate them with the help of Android device, then it can be something great. And JDG helped me a lot to get introduced to the Android, as I'm from a hardware background. In the JDG, I used to attend various workshops, like it was on Firebase, Android, Cloud. Everyone is learning from someone else. It was like growing up together and making something wonderful.
We were mentoring him in terms of working on Android and working on latest innovative products.
My school granted access to those students, and I developed something for them. They can listen to the pronunciation of each and every alphabet with the help of this app. So that's why I added the Google Voice API. So they can type the different words and they can actually listen to its pronunciation, and they can gain confidence to speak also.
If Amaze instrument is widely available, that will help to the children who cannot afford the surgery to hear at the very early age so that they can develop speech.
There are a lot of problems are there. Of course, I am feeling very proud. We should do something for our community.
I think we should have many people like Ame who thinks like real world problem can be solved by the technology.
To look at that happiness on the face of that person who is using my technology. This is the definition of satisfaction for me.
So that was a story about Ame and how community helps. So GDG is Google Developers Group, and they have all over the world. I think TFUG is one of them. So TFUG is also a community for like-minded people to come together. So this was a story about Ame, and I was pretty interested in his story because first of all, you have a solution, you look at this, you have a problem at hand, and you come up with something to actually improve and try to see if you can help a specific member of the society who probably is underrepresented due to any reason. So a big thanks to Amit for actually coming up with something and helping people. So with this in mind, let's quickly now. So we have covered three sort of applications that are very helpful, and I felt that it was pretty unique to India. And of course, as Ame mentioned, that we have option of surgery when it comes to hearing it, but the problem with surgery is that it is pretty expensive. So what Ame made is a low cost alternative, and of course in India, because we don't have a lot of resources, low cost alternative is always the best option. So let's quickly jump to some of the things that you could do. So uh, I believe in making open source contributions, and I'll show you a couple of videos that I have made, and I have what the work that I have is actually done in open source, and how is it useful. So this is one of the first project that I did. It's called as Emojinator. So uh, given the shape of my hand or the the gesture that I'm making, I'm trying to predict the emoji that is associated to it. Okay, so at first does not make a lot of sense. I mean, does not have a lot of application, but I will try to cover all these questions, and I'll try to answer all of them at the end of the session when things become much more clear. So for the sake of understanding, just have this thing in mind that um, this is I think initial project that I did back in 2018, and at that time I just wanted to present my work. So this was one of the fun things that I did, and I did not understand actually what are the actual benefits of it. But anyway, it looked cool. I used computer vision and machine learning, so I integrated these two technologies, and I came up with something which I felt was pretty interesting. So then I started doing more, I started doing more complex work. So then I worked on Google's Quick Draw dataset. So if you have not heard of Google's Quick Draw, it's basically Google has a dataset of around 20 million drawings or doodles, and Quick Draw is an application from Google where you can draw a doodle, and machine learning algorithm will recognize it, whether the drawn picture is of a bicycle, or if it is of a hanger, or if it is of a slice of pizza. So I took that the same concept, and I tried to do it using my own model, which was lightweight, and I tried to do it using a computer vision technique. So I was drawing on the screen using some computer vision techniques that I learned back in undergrad, and it made sense at that time. And I was lucky enough that Google actually saw my work, saw the contribution, and they felt that it was original enough. And then they included this implementation in their own open source repository. So now, if you look at Google, if you search for Google Quick Draw on GitHub, you will get a link to Google's official GitHub repository, and in that you will also see my contribution, that I have made this real-time Quick Draw implementation using computer vision and machine learning. So slowly, I started moving towards the application part. I started making uh, things that were lightweight, and making models which were lightweight and could be reproduced quite easily. And then I started working on some research projects. So I came across this research project. It's end-to-end learning for self-driving cars. So this is one of the initial papers that were given by NVIDIA, or published by NVIDIA, where they covered one of the aspects of self-driving cars, or autonomous cars. So this concept is called as behavioral cloning, where you given an image of the road, you have to predict the steering angle. So self-driving cars have a lot of modules. Maybe path planning is one of them, object detection is one of them, traffic signal detection is one of them, and then behavior cloning is also one of them. So I came up across this research project, and the important thing that I did with this research project was to make it lightweight. So the initial paper that I saw had a complex architecture of the model. So it could not run on my. So the initial thought was just to reproduce what was written in the paper. But because my laptop, or my laptop at home was not powerful enough, then I explored computer vision techniques. I came up with my own filters and certain scaling techniques, so that I could scale down the images, so that I could train it on my local machine, and then I could see the results. So not I was not only working on research papers, but then I was also trying to improve the research papers. So that's how I started progressing. And let's look at the video of how it exactly ended. So this is the actual video. So you can see that the steering wheel is turning left, and it's not very accurate, because now you can see that due to pedestrians in the image, I had an issue. I mean, the model had an issue with where exactly should it steer. But if you look at long roads, or if you look at long drives where you don't have a lot of noise on the road, the model works pretty good. So even though we had a couple of pedestrians or cars, that's still fine. A model can work on country conditions, but when it comes to city conditions, slightly fails. First of all, because I was just trying to implement something quite simple, so I did not want to get into the details of how to make it work for dense conditions. But at the same time, this was one of the initial research papers by NVIDIA. It was not very well defined. The scope was not very well defined, but I was pretty happy with the outcome. So the thought behind is that open source contribution definitely helped. I read a lot of papers. I read a lot of blogs on the same, and then I came up with an implementation. And I found it pretty useful, because it makes you learn a lot. At the same time, it also helps or inspires other people to learn and come up with new techniques of their own. So if you want to have a look at any of the video that I just mentioned, you can look at the slides. You can look at my GitHub page, and on the right you can see my website akshaybhadur.com, where you can log in and see all the work that I have done. Now, the three aspects to a great presentation. So I'm trying to be a good presenter from now on. Not trying to include a lot of code. So the three aspects are the content. Of course, the content has to be really important. It has to be uh, relevant to what I'm trying to, convey, and the story. So the application part that I introduced with Ame's story, or with Tanya's story, or with all the other stories that I kind of covered, gives a sense of, I feel, uh, it gives a sense of continuity to the whole presentation. But now the most important aspect that I want you guys to take away from the whole presentation is, of course, the takeaway. So now let's discuss the takeaway. What exactly I want you guys to take away from this presentation or this session. So I want to discuss an experiment that happened. So this is done by a YouTuber named as Mark Robert. He's also a research scientist at NASA. He did his master's from University of Southern California, and he makes his YouTube videos just for fun. So what he did was he came up with an experiment. So the goal of the experiment was to make sure that your car reaches from the start point. Your car reaches from the start point up to the end point. Okay. So you start from this location and you end up going towards the win location. Okay, quite simple. And you don't have to code. These are some of the what I said. These are some of the um, instructions that you have to take. So if you try to break it down, mostly these are loops and these are break conditions, and anybody could follow them quite easily. So anybody does not have to be an exact coder to solve a problem. So if we play the video, yeah. So if we play the video, so this is me trying to do the experiment. So I'm just trying to arrange the blocks, and then trying to make sure that my car starts from the start position and then it reaches the end position or the win position without stopping in between. And in the first try, I think I failed. So if you see that I could not get in the first try, uh, and therefore I had to modify it a bit. Therefore, now if you see that I added a block, and after that, because of all the pieces of instructions, my car was able to reach the finish point. And if you see in the corner, you had a total score of 200 points. So if you did this task correctly, you will get 200 points at the end of the session. Okay, and and just to remind you, these points does not have any value in the real world. So the score that you get, 200, it does not have any value. Nobody's going to remember it. Nobody's going to even ask you if you have done the program, or nobody's even going to find out if you lied. But one thing that happened during this experiment was that there were two sets of instructions that were given. So in the first try, if you did not get, you will get a message that that did not work. Please try again. So simple as that. Now, in a couple of other folks, what they got was you started losing 5 points for every wrong attempt. Okay, so earlier you had a total score of 200 points, so you can score 200 points. But if you failed in the first attempt, then 5 marks will be deducted, and these points does not have any value in the real world. Okay, so now let's look at what exactly happened. So what the experiment proved was quite interesting. Okay, so if let's look at this graph. So the total number of people that actually solved the problem, if they were getting -5 points after the first wrong attempt, were 52%. So out of 100, only 52 people were solving the problem if they got a negative penalty. Whereas if there was no penalty, people were were solving up to almost 68%, and that's a substantial rise. Now let's also look at another interesting fact. So if people were getting -5 points for every wrong attempt, they were only on an average were trying for at least only 5 tries. Okay, and if you had no penalty, then people are going for 12 tries, right? So that's more than double. So what that reminds us is that if we don't have the fear of failing, we keep trying it again and again. But if we have that sense of failure, or if we feel that we'll be ridiculed, then we stop giving it a try. And so if you add this all up, what we need to do, if you have come up with a solution, or if you have to solve something, we don't need to think. We all only need to just do what is required. And I implemented this. So I thought about this video, and I saw the video, and I found it pretty interesting. So what I did was I came up with an idea for Indian Sign Language recognition. Okay, so it sounds pretty similar because we already have American Sign Language, and we also have the data set for that, and also we have competitions. Uh, but but I actually wanted to solve it from the ground up. So what I did was I went to an NGO, okay, to an institute in Pune to actually learn sign language. And when I was learning sign language, I realized that there are a lot of issues that are currently going on with sign language. Let's look at some of them, and let's look at how to try to solve the issue, and then we'll discuss it as we go forward. So the problem statement is we have around 40 million people in India who have speech and hearing impairment. Now the distance between Mumbai and Pune, where my family lives and where I stay and where I work, is around 80 kilometers. And within that, we have differences in sign language. So what I wanted to make you understand is that sign language is not universal within India. Now let's look at an ideal solution. So the ideal solution should be to standardize ISL like the American Sign Language. Second is using AI to predict minute changes in signs and symbols. Third, and the most important that I believe, is keeping the resources as low as possible. So as already mentioned, the solutions for Indian problems has to be Indian in nature as well. And because we know that India does not have a lot of resources, therefore we cannot expect for a machine learning model to work, even though even though we feel that it might be the same for, let's say, other countries, other developed countries, because India has different resources, it has different infrastructure. We have to come up with a solution that is Indian in nature. So what I did was I spent time at an NGO, and here's a video of the preparation part. So I was recording a couple of students from the Deaf and Mute Institute, and they were helping me with some of these alphabets and letters initially, and I think they were quite helpful in making me understand the problems. And you can have a look at the entire video. This is a 5 to 6 minutes video, and a couple of other important instructions that were given to me by the faculty members from the sign language institute. So I came up with different solutions. So first was just using your hand gestures. So as you can see that I'm using a color segmentation technique, and using computer vision and a machine learning model to actually actively segment out my hand gestures from the entire image. And I'm trying to predict all the alphabets that I learned from the sign language institute. So you can see that because of the color segmentation technique, I'm getting a good frame FPS. I'm getting around 40 FPS, even though I'm not using any GPU. I'm not using any major uh, computer. I'm using a simple CPU with low RAM. So I just wanted to make sure that it runs quite well. And then of course, if I have to make it in an application, I can use techniques like TensorFlow. So yeah, so the point is, then I realized that just using your hand gestures was not enough, because uh, with just hand gestures you can specify, or you can identify only, let's say, letters, alphabets, or some sign language gestures. But I wanted to include more. Therefore, what I decided was I needed to come up with extraction of my facial key points as well. So then I realized that these are the couple of gestures that that I understood or that I learned from sign language. And in the model, I actually ended up working with around 20 gestures. These are some of the 8 gestures from that model itself. So now you can see that I'm not working with the entire image. I'm only working with my facial key points and my hand. So it reduces a lot of noise. It reduces the amount of effort that is needed by the computer to make predictions. Therefore, it's very fast. So if you look at this video, this is a prototype, which I'll say is I'm using facial key point tracking. So I have key points around my eyes, my nose, my lips, and my jawline. And with the help of these key points as well as my hand gestures, I'm able to come up with a machine learning model that works on low resources. At the same time, using computer vision, I can extract out only the required information. Okay, and if you can see in the background, I have added a lot of noise because I wanted to make sure that even though I might have some noise in the background, my model would at least be successful even in that case. So this is only the a prototype. I mean, I'm still working on it. There are a lot of issues that have to be addressed. But the important point that I wanted to mention is that even though I had these issues, I think what the community wants is for people to address them. And I got a chance to present my work. I got a chance to go to Google's headquarters in California, and I presented my work. So just going to play a small snippet from it. So this is me presenting my work at
Just wanted
Google
to thank each and every one of you for coming
conference.
here and actually listening to me. And it feels really great to actually not only represent my community but also my country at this stage. So this is my first.
So you can look at the entire video by if I mean you have a look at the slides, and if you want to have a look at the entire video, please do that. So the important point that I wanted to mention is that if you have a good use case, if you have a good if you have a unique use case, if it's a social issue, if it's something that you're working on is will help solve problems of a lot of people, then communities will help you, in whatever capacity that they can. Now, I'll discuss one more thing. How could exactly you help? Now, this is the main point that I wanted to mention. Is first identify a problem. So in my case, I identified that the sign language community in India was underrepresented. Okay. Then I came up with a rough draft. You can do the same. I thought that I just come up with because I had previously worked with hand gestures, like the emoji data project that I made you saw. I thought that I can use something similar and come up with a solution. Then what do you have and what do you need? So for me, I knew that I had some technology background, and at the same time, I understood that I needed to spend more time with actual deaf and mute community. Therefore, I went to the Sign Language Institute. Then I learned sign language, and of course, I asked my friends to be a part of it. I asked my friends to collect data set from me. I asked my friends to give their viewpoint so that I was sure that I was not missing out on anything. And the most important aspect is start. And I know this because I procrastinated for quite some time. I had this in the back of my mind, but I kept delaying it. And then eventually I thought that, just let me just give it a try and see where it goes. Now, one more thing is I think Google is doing a great job. Google's AI lab in Bangalore. I got a chance to meet. I think Usha also met the head of the AI lab. He's, I think, also the director of Triple IT Hyderabad, and they are doing an incredible job. So just to give you a brief about the AI lab, so AI lab is I think only present in I think 6 or 7 countries all over the world by Google, and they are trying to solve issues that are particular to that region. So I think there are 2 in the United States, 1 in India, 1 in Europe, and I think 1 in Singapore as well. I'm not exactly sure. But let's look at what are the problems that they're trying to solve, and those problems are very unique for India. So first is of course they're trying to detect diabetes from looking at the retina. Then they're doing flood forecasting, which is quite prevalent in northern India, especially in Bihar. And also they're teaching kids how to read. Now, detecting diabetic eye disease. I'll not take much of your time. I think we're almost at the end of the session. I'll quickly go through them. So we have a healthy retina. It looks like this. And then if you see hemorrhages, we have, we kind of make sure we can make a prediction that, the person might have diabetes. So this is one of the research things that they're working on. And I found it pretty interesting because healthcare and agriculture are two major components. And these two fields have a lot of I think have a lot of potential for machine learning. So the wheel killing robot that you saw initially, and now this project, I think, or this actual implementation, I think if both of them happen in India, it's going to be very helpful because we have a lot of other use cases related to agriculture and uh, uh, healthcare. So yeah, now we have something for flood forecasting as well. So if you guys don't know, Bihar is prone to a lot of floods, and I think it occurs almost every year where a lot of people lose their land, lose their lives. So what Google has done is that they make predictions, and at the same time, because every mobile phone has Google in them, so they just send you a push notification and giving you the risk near your place. So this is something that they're working on. If you want to read more about this, they also have a blog on that. It's present in the slide deck itself, or if you want to get links for that, you can search it on Google, or you can reach out to me. I will send you the links. But I found it pretty interesting. Now, the last project that they're working, I think they will be working on more of these projects, but I could only find 3 of them, and I found these 3 pretty interesting. And third one is called teaching kids how to read, and it's through an app called as Bolo. So we have an app called as Bolo, and if let's say a kid does not know how to read, they can just recite and get points accordingly. So it's like a game, and of course you can also learn how to spell new words in Hindi language. And it has a good interface. This application uses machine learning NLP for uh, coming up with these techniques. So have a look at that. Have a look at the blog as well. Found it pretty interesting. This is also present in other languages. So this is also, I think, present in Latin America. I mean, not exactly sure about the details of it, but I found it pretty interesting. So if the kids, if they don't have a lot of resources to learn, or maybe the parents are not fortunate enough to help them with the studies, then technology can definitely come to the rescue. So this was it. I just want to discuss these applications with you. I wanted to get your feedback on that. So let me know if you have any questions. You can reach out to me on LinkedIn. You can reach out to me on Gmail. You can reach out to me on my link on my GitHub profile. You can reach out to me on my personal website as well. And if you have any issues, or if you feel that my presentation should be improved, or if you feel that you want me to work on some problems, let me know. Give me your feedback. Go to akshabahadur.com and then leave your feedback there. So this is it. I had a great time. So you can find the content at bit.ly/tfug-mysore. You can find me on akshabahadur.com. So this is it from my side. I had a great session. I'll see you next time. We probably cover more complicated or more technical projects. Or if you want something like this, please let me know. We can have another session set up, and I'll try to give you the knowledge that I have added over the years. All right, so I'm going to stop recording my screen. All right, so I think I got a question. Sunil has asked me, so does ISLAR help in recognizing sign language in a different part of the country? So currently it does not. Currently it only has feature for, oh, I think I've got around 12 comments. Yeah. All right. So yeah, so Sunil, currently this is only meant, I only made this for Marathi Sign Language. That is the local sign language for Pune and Mumbai. But the plan is to make sure that we can, I open source it as soon as I can. I want to just make it mature a bit. And then other people from all over the country can use that as sort of a ground truth and then break it for their own region languages or region sign languages. But at the same time, I also want to come up, work with the Indian government to make sure that we have one standardized sign language throughout India. That is not, I mean, that is not present at the current step, but definitely I think within the next 5 to 10 years, we want to make sure that we have one universal sign language so that people from North India can even travel to South India without having to worry about learning sign language. So that's my take on it. Thanks for the session, all of you who joined in. Let me know if you have any questions. Usha, let me know. I mean, should we stop the recording or do you have anything else in mind? Yeah, I mean, having said that, I'll wait for Usha to reply. Yeah, so I think Usha is going to end the broadcast now. I had a great time. Thank you all for joining. I hope you stay safe, and I'll see you next time.